Is planetary spin an energy field? We usually think of spin as just a property, a number in the data set. But what if spin is actually a kind of energy field, like heat or gravity, something that holds energy and interacts with space? This short video looks at planetary energy patterns to explore that question. Are these energy fields connected? In most physics models, mass, gravity, heat, spin, and magnetic field are treated as separate forces or properties. But what if they're really just different ways energy organizes itself in space? At the planetary scale, these energy fields tend to move together, as if they're somehow interdependent. It could be a coincidence, or maybe it reveals a deeper pattern that's been overlooked. Do these energy types stay in balance? If these energy types are related, we might expect their values to follow a pattern across planets. Maybe there's an ideal standard that planetary systems are trending toward, or recalibrating to, over time. Mass and gravity are clearly linked. That part's well understood. But what about the other energy types? So we asked a simple question. Do the numbers line up? Normalized energy by planet. To compare everything on equal footing, we normalized each energy type from 0 to 1. This chart shows 4 types: spin, heat, magnetic field strength, and gravity, all plotted by object, from lowest mass on the left to highest on the right. Gravity was calculated at 1 astronomical unit for consistency. Other values reflect each planet's internal or surface level properties. It's not a perfect method, but it does show a strong overall correlation. What do the results show? The data shows a clear pattern. These energy types tend to track together across the planets. It's almost like there's a natural balance most systems settle into. But some objects stand out. Venus and the Moon, for example, have almost no magnetic field and very weak spin. So what happened? And why don't they fit the pattern? The weakest couplings. The correlations between mass, heat, spin, gravity, and magnetism are strong, even with the outliers, and that tells us there's a real connection. It also gives us clues about how these energy types interact. When a system deviates, it may have experienced a collision, tidal locking, or a frozen core, events that leave lasting imbalances. And those imbalances reveal something deeper. Some energy types only interact weakly. Gravity and spin, for example, show the weakest coupling, and their connection may only become visible in extreme environments or over very long time scales. That's likely why the link has been missed before. The interaction between energy types is slow, subtle, and hard to detect without the right model. Planetary spin is an energy type. This entire idea is grounded in information theory, where particles that define motion cause the results we interpret as energy. And if that's true, then energy types like mass, heat, spin, gravity, and magnetism shouldn't be isolated. They should be part of a shared system. The correlation data supports that. These properties generally rise and fall together across planetary systems. Spin appears to be part of that pattern. There's still a lot to unpack. We'll need data from hundreds or even thousands of planets before we can map the full picture. But this model gives us a new way to think about spin, not as a leftover, but as part of the planetary energy structure.